All right, guys. I got to post two videos today. This first one is actually a pretty cool problem. Okay, like this guy. So we take a look at that and notice we've got some X's and Y's intermingled in there, and looks like we're going to have to deal with it. So first thing that jumps into my mind is some sort of implicit differentiation. Okay, but before we get into that, how about if we take these guys and we pull the X's and Y's apart, okay, using our product rule, okay, for logarithms. All right, so this is log base 8, that's log base 10. So let's see, when I pull these guys apart, I'm going to get log base 10 of x plus log base 10 of y. Okay, and on the right side, I'm going to get log base 8 of x, okay, plus log base 8 of y. Okay, so now it's just a matter of going back to what we were doing earlier this week. Okay, I'm just going to differentiate straight through, okay, going back and using this rule, okay, and see what happens. Okay, so let's see, when I differentiate here, my u is just x and my a is 10. Okay, so it looks like I'm going to get 1 over u, which is just x, times the natural log of a, which is 10, times the derivative of u, so I would get dx dx, okay, which is just 1. Okay, so let's see, now this guy, okay, my u is y and my a is 10, so I'm going to get 1 over u times the natural log of 10 times dy dx, and that's exactly what we're looking for. Okay, so the left-hand side I got. Right-hand side. Okay, this guy right here, so my u is x, my a is 8. So I'm going to get 1 over u, which is x, times the natural log of a, which is 8, okay, times dx dx, which is just 1, so that's nothing. Okay, right here, it looks like my u is y and my a is 8, so I get 1 over u, which is 1 over y, natural log of a, so that's 8, times dy dx. Okay. All right, so I've got a term here and a term here with dy dx, so I have to get those together. And then if I get those two together, it would make sense that I would get this guy and this guy together. Okay, so I'm going to collect these guys on the left-hand side, and at the same time, I'm going to factor out dy dx. Okay, so on the left-hand side, I factor out that dy dx. Okay, so let's see. This guy's already there, so he stays positive. 1 over y natural log of 10. But then this guy comes over and becomes negative, so it'd be minus 1 over y natural log of 8. Okay. All right, so let's see. This guy's already on the right-hand side, so he stays there. 1 over x natural log of 8. And then I bring this guy over so it becomes negative. So it'd be minus 1 over x natural log of 10. Okay, now I know I'm going to divide both sides by this guy. Okay, but notice when I do that, I'm going to get a complex ratio, which I don't like. So why not combine these into one ratio, one fraction, and combine these guys into one ratio or fraction, and then multiply both sides by the reciprocal of whatever I get over here. Okay, so let's make life easier on us. Okay, so let's see, the common denominator. Well, they both have a factor of y, it's already there. Okay, and so I'm going to need a factor of the natural log of 10, and I'm going to need a factor of the natural log of 8. Okay, so let's see, over here I got to multiply above and below by the natural log of 8. So that gives me natural log of 8 minus, here I'd have to multiply above and below by the natural log of 10. So that's a natural log of 10. I do the same thing on the right-hand side. So let's see what I get. Okay, I have a common factor of x, so that stays there. I need a factor of the natural log of 8, and I need a factor of the natural log of 10. Okay, so here I have to multiply above and below by the natural log of 10, so that gives me the natural log of 10, minus, here I'd have to multiply above and below by the natural log of 8, so that's a natural log of 8. Okay, so let's see. I multiply both sides by this reciprocal, so that isolates dy dx, which we're trying to do. So over here I'm going to have the natural log of 10 minus the natural log of 8 over x times natural log of 8 times natural log of 10 times the reciprocal here. So I get y natural log of 10 times natural log of 8 all over natural log of 8 minus natural log of 10. Okay, so let's see what happens here. Okay, how about that? Natural log of 8 goes with natural log of 8. Natural log of 10 goes with natural log of 10. Okay, now that's natural log of 10 minus natural log of 8, but this is natural log of 8 minus natural log of 10. Okay, so those don't necessarily cancel each other out right now. They will though. Okay, so let's put things together. Okay, so I'm left with y times natural log of 10 minus natural log of 8 all over x times natural log of 8 minus natural log of 10. And lo and behold, how about this binomial here and this binomial here are opposites of one another. So the fraction formed by this binomial and this binomial reduces down to -1. So we just get the opposite of y over x. And isn't that cool? Okay, very cool problem. Okay, so I'm going to upload this guy. When I'm done, I'm going to get to the last video.